Hey everyone, this is Will. Welcome to I don't remember anymore, miniKanren 12th, maybe? miniKanren Uncourse, something like that. Starting to lose track of the numbers, which is good. So, been able to keep it going pretty regularly. I was a little worried that we'd have lots of weeks we had to miss, but been pretty good at protecting my Sundays. So, thank you everyone for joining, either sort of live or watching after the fact. Okay, so this is the part of the Uncourse that is sort of uncharted. And we got into that a little bit last week. And the reason I'm calling this an Uncourse is that the course part of it is basically over, right? You know, the course part is me talking and doing lots of live coding or whatever. And now we've covered most of the fundamentals of miniKanren. There are obviously many, many things we could talk about that we haven't covered at all. Things like nominal logic, for example, or tabling, or a zillion of those things. But we have enough background now that we can actually start looking at open problems or current research or whatever, right? And last week was really cool. I basically didn't have to do anything other than talk to people and ask them questions about their really cool projects they've been working on. So there were three projects we saw last time, and that was really neat. So we saw Orchid's microKanren with disquality constraints, and let's see, we also saw a cellular automata in miniKanren, a relational linear cellular automata. That was cool. And we also saw an editor called Veneer that includes a full version of microKanren. And since last Sunday, there's actually been lots of work. So David and Orchid both made lots of changes, and I even tried to write some JavaScript basically for the first time ever. Try to help a little bit with some of the constraints. But the cool thing is we actually, well, I shouldn't say we. I really shouldn't take credit for this. But there is a very cool new version of Veneer. So hopefully we'll see that. So, but anyway, the bottom line is we're getting to the point where, let's see. Next. We're getting to the point where I don't have to talk as much, right? If you want me to talk about something, I'm happy to do so, and I'm happy to show people what I'm working on, but other people have cool projects they're showing off, and the stuff I am going to show, I'm hoping I can show like real researchy things or things under development. Some of it may not be research, maybe they're things we want to take from existing logic implementations. It's more engineering work, but some of it is research. So anyway, I'm very excited about that. I don't know how this is really going to go. Lots of possibilities. We can start getting into more collaborative programming, trying to do group or some sort of pair programming, can take it offline. I've already done some of this, pair programming with people in chat, sort of outside of these hours. Be happy to keep doing that. Obviously, Orchid and David and I did, we were collaborating on the editor virtually. That was really cool. I had lots of discussions on Twitter and stuff like that. And also, we could try exploring some really unusual things, right? I mean, to me, it's very exciting that we have this extremely powerful technology where people around the world, I don't really know who some of these people are, right? I've never seen their face. I don't know anything about them other than their handle. But we're collaborating on real research. I think that's really cool. So we could even try something like a collaborative writing of a paper or something like that. That can get tricky with authorship and stuff. I don't know. We could also try doing collaborative tutorial. I don't know. Try whatever we want. I think this is a chance to try the sorts of things that you don't see in like a MOOC That's why I didn't want to do a MOOC, right? I mean, I want to do something small where we can kind of hack together. Anyway, so now we're in the fun part of the course where I don't know what's going to happen. Just like last week, I'd like to open up the floor. Obviously, if David and Orchid want to show off anything with the really cool Veneer editor, that's something to talk about and to show off. It's gotten much more capable since last week. And if anyone else has anything they'd want to show off or talk about, and also, once again, I'm always happy to show off some of the problems I'm working on or some of the hacking I've done recently, show you sort of the state of the art and some of the things I'm doing with relational interpreters and where I'm stuck. Lots of open problems if people want to help with that also. Okay, well anyway, so welcome everyone. Got a couple of new faces and some folks I've seen before, but maybe not in the Hangout also. So welcome everyone. Thanks for showing up. Okay, I will first ask David Norkid, would you like to talk about the Veneer stuff at all, the progress that's been made in that area? Or would you like me to talk about it? Show it off? Yeah, okay, great. So let me make sure I get the cameraman. I didn't set up all my tech. So let me make sure I've got the cameraman thing so I can give focus to people. All right. David, you want to do some screen sharing?
Okay, yeah, I think I have it set up this time.
Okay. Is there also a YouTube stream link for the people who are watching? That's a good question. There should be a way. I think if you try joining again, if you open up a browser window and try joining again, I think you can. I think it'll ask you, and maybe gives you the link. I'm not sure exactly how that works though. Okay. So, David, could you bump up the font maybe just?
Yeah.
Great. Perfect. Thank you.
Okay, so since last time, what we've done is we added some more of the miniKanren constraints on top of our microKanren implementation, starting with occurs, and then we had there's disequality, symbolo, numbero, absento. So those are all there. You can look here. We matched them all into this normalized constraint store at the end. It's a bit less complicated than the miniKanren version. And so what that allowed us to do is have the full relational interpreter that we did in the earlier Hangouts inside the browser now. And so anyone can go there and run that. And so it's actually surprisingly fast for the implementation, which I didn't expect because I'm not even fully compiling to JavaScript. So so here we can generate a quine. Oops. There. So it's almost instant, which is pretty surprising. When we did the Hangout in before, when we ran the appendo in chicken scheme in the interpreter, just running append backwards took several minutes, and here it's instant. It's actually running faster than compiled chicken, compiling the scheme or to C.
So why do you think that is? Why is it so fast?
I guess it's just JavaScript engines are just ridiculous now, I guess, because I'm not. What I mean by I'm not fully compiling to it is I'm compiling it to closures, and I can give you a little. I can show that a bit here. So here in application, so there's Lambda, and basically just taking the code and making a simple closure out of it. And so application here, what I'm doing is I'm actually building up an array of the arguments, and I'm concatenating it with the array that's the current environment, and just passing that into the next expression. So that would normally be really slow, like if I was doing that in Scheme, but here apparently it's faster than compiling down to C. So that's kind of exciting because if I get this fully compiled down to JavaScript, it's probably going to be faster than miniKanren running in Ches Scheme.
That's so mind blowing to me. I mean, I think Alan Perlis has had something where he's talking about how programming languages don't escape their embryonic sac, and certainly in terms of perception, right? I mean, I remember when JavaScript first came out and how slow it was, right? And the idea that this could be beating like real compilers, right, for some definition of real, just it's hard for me to understand. So one question I have about performance. I think Orchid mentioned something on Twitter about the search strategy maybe being a little different, or something about the search strategy. I wasn't sure of that. Is it the most sophisticated version of the microKanren search strategy, or is there a different search strategy going on?
No, it's just using the plain microKanren search strategy, and we don't swap the second case of m plus either. So it's just the first example of it in the paper. And
okay. Have you tried it swapping the other way? Because I think that the other way is supposed to be better in some sense. Although I don't know, maybe you have more closures being created.
I did try it, and it seemed to be the same. For all the examples I tried.
Interesting.
And the most stressful example right now is probably the Oleg number stuff. So you can go there and try that out too. It's actually pretty crazy how fast it runs. So this is just running multiplication backwards. And the other things that I'm looking forward to as far as performance is we can do some of the stuff David did with core logic, because one of the things he did is he has this library where he ports the persistent hash map to JavaScript. So we'll be able to use that.
Okay, so you won't have to use the association list to look them up. It'll still be triangular, but it'll still be a triangular representation. Is that right? You may have to do multiple lookups in the hash map. Okay, but each lookup should be very fast.
Yeah, I haven't decided exactly how to do that. I was watching the old Hangouts where David was explaining the ways they've tried it. So I'm not really sure yet, and I don't know if Orchid wants to talk about it, but we're also looking at other ways of adding constraints other than just sticking them in miniKanren like we have been. For example, I don't know how familiar you are with Alexei Radul's propagators, but that's one of the things I'm interested in a long time. So that's one of the things I've been trying to do.
Yeah, I ran the Scheme workshop 2 years ago, and Alexei was our keynote speaker and spoke about propagators.
Mm-hmm.
So that's there are obviously lots of connections between the propagator stuff and logic programming, and also truth maintenance systems, and there are a bunch of things on that in that space. So propagators I think would be a really interesting way to look at this. There's also attributed variables. Which is sort of another way to implement constraint logic programming, and that's a standard way to do it, which we haven't played around with a lot, where you have the constraints on the variables themselves to avoid having to look at all the constraints in the constraint store. The idea is to only look at the relevant constraints, not all the constraints when it's time to solve them.
Yeah.
And there's also constraint handling rules, which is designed it's like a DSL for writing constraint rules. So there are lots of ways of implementing constraints that we haven't even really experimented with that might be much better or have different trade-offs at least. So that'd be cool. Propagators are really interesting. So one question I have is how hard would it be to print out, in addition to the substitution, to print out other information from the constraint store as part of the answer?
Well, that'd be that'd be pretty easy. And I haven't. That was one of the last things we were going to work up for the Hangout, but didn't get a chance to. It's still going to be a bit tricky, but it's um, the reification is going to be a bit nicer in this layout because I can do stuff like make a table, like have constraints next to the variables or whatnot. But it shouldn't be any more complicated than doing it in Scheme.
Cool. Let's see. So, oh yeah, okay. And then the last question I had was with the Absento. So you have a somewhat restricted version of Absento. Is basically the Absento that was in the original Quine's workshop paper, where the first argument is restricted to being a symbol rather than a general term.
Yeah.
And in many cases, that's all you need, probably most of the cases. But there are actually some really interesting things you can do if you have a more generalized Absento where you can take an arbitrary term as the first argument. And I'm just wondering, now that you have the symbol version of Absento, if you have a sense of how hard it would be to add the generalized version, or if you'd like, I mean, I'm certainly happy to try to walk through that code or that algorithm. I know that in some of the versions of miniKanren right now, it's hard to see how the constraint solving works because it all gets kind of tied up with the fixed point solving and stuff. It gets really messy with the representation. But the algorithm isn't that complicated for solving the more general Absento, so it might not be that hard to generalize it. Okay, so to give you one example of an interesting thing you can do, if you represent numerals as piano numerals, so like z, the symbol z for 0, or successor of z for 1, or successor of z for 2, and so forth, that has a neat property that you can take you can add 1 to a number without looking at the underlying number itself, and also you can subtract 1 from a number with only looking at the outer layer of the number. So you can leave the rest of the number as a variable in many cases. And you can even do, you can enforce constraints like one number is smaller than another by using the generalized Absento. And you can say, n is smaller than m if they're both piano numerals by using Absento constraints, saying that n doesn't appear in m. So there's some really interesting things you can do with generalized Absento. So that would be, that's a feature request I have if it's. I don't think it's that much harder. To be honest.
Okay. Yeah, definitely on our to-do list.
Now the other thing that'd be really cool, and I don't know how to do this. Okay, I don't know how to do this yet, but the two other things that'd be sort of obviously very cool. One would be, talking about core logic, would be to have something, obviously something like the matchy interface would be nice, but I think the finite domain constraints, obviously that's more of a challenge, but thinking longer term, that might be a neat thing. And then the other thing that I think is really cool, although I don't know yet how I don't know exactly how this is going to work. Michael Adams at Utah and I have been looking at adding these tree automata-based type constraints to miniKanren, and I think that's going to give us tremendous power. So I'm not sure. This is something I'm still working on, trying to integrate into miniKanren. I should know more next week. But if that pans out, that will actually replace a lot of the constraints that we have in miniKanren, a lot of the symbolic constraints. You'll be able to express those as a user level by writing down a little grammar, like a recursive grammar, expressing the sort of the values in your program. And so that a lot of the uses of Absento and Symbolo and Numbero, those will just kind of go away. And to some extent, you'll be able to just define those yourself as the miniKanren user. But it'll be way more powerful. So if we can figure out how to make that work the right way, that would be really cool, and that might be a different approach also to doing the constraints. All right, very cool. Does anyone else have any questions? Yeah, and in fact, now there's technology for embedding this in a web page, right? So you could have a web page that has, like if you want to do a tutorial for miniKanren or show off some miniKanren code, you can have a web page that has different embedded sort of like mini REPLs or mini like little boxes with code that you can execute the queries on individually.
Yeah, so if anyone wants to make like a miniKanren demo, you can go to the Veneer repo and look at the examples, and it's pretty easy to set up.
Can you click on the quine-generating?
Oh yeah, okay, so I made one here. Like it walks you through the relational interpreter and the generating quines, and it makes a twine too. Takes a minute, so I'm not gonna run it here. It'll log on my browser for about a minute. So, but yeah, it's really easy to do if anyone wants to make a miniKanren tutorial. And if you have any requests for like different layouts you want, I can do that too.
And I tried this in every browser I had access to on Windows and on Mac, and it all seemed performant on all of them.
Okay, awesome.
Yeah, it even worked under Windows on Internet Explorer, which also is something that kind of blows my mind. But yeah, so that's so cool. I mean, this really is by far the most portable implementation of miniKanren that there is now.
Yeah, so Daniel, currently I am doing that. What I'll be able to do in the near future is just every time you run a query, I'll be able to spawn off. I can use either web workers or a hidden iframe, so that essentially starts a new thread, and so it won't lock up your main browser. And what you'll also be able to do with that is have like a time constraint on, like if it doesn't return a certain amount of time, just kill it.
So this would let you use that browser window while a query is running, right?
Yeah.
So it's not blocking. And you could even, I guess, execute a few queries at once and let them run.
Yeah, you could even parallelize. Yeah. Because browsers will do, if you have a hidden iframe and you send it JavaScript to run, they'll just start up a new process for every single one, and it'll run on different threads.
Oh. So parallel miniKanren queries is also something I've been thinking about. I wonder if this would be an interesting framework for exploring that. Yeah, because you can parallelize miniKanren in different ways. You can try to make the implementation of miniKanren deeply parallel, which can be tricky, but yeah, I've not successfully done it and gotten a speed up. But another way you can do it then, in some sense, is easier, is to parallelize the query, if you will, and say, hey, I'm doing this relational interpreter. I'm going to sort of unroll the query, the condes at the top level, down 3 levels, and then spawn off like a bunch of, individual subqueries and let those run in parallel or something like that. So that might be an easier way to do some more coarse-grained parallelism and try to avoid some of the overhead. All right. Well, this was really very cool, very exciting. I've been showing this stuff to Dan and Jason. They think it's really awesome, and the fact that it runs in the browser means that if we're teaching a course on miniKanren or have a blog post or something like that, it doesn't kill some server with everyone hitting it simultaneously trying to run their queries. And also, since people want to write queries that might diverge, right? That's kind of hard on a web server. If you had 1,000 people hitting it with queries that might diverge. So anyway, that's really neat. That's very cool stuff. So thanks a lot. Thanks for showing that off. Okay. Very cool stuff, and it's already one of the best implementations of miniKanren. In some ways, it's the best implementation. So hopefully it'll keep getting better, and that'll be really awesome. Okay. Any other things that people would like to show off or talk about? Any projects people have or anything like that? If not, I can show off some of the things I've been working on, or we could do some live coding or whatever. Any other takers? Okay. Well, let's see. We could do a couple things. So let's see what people want to do. We could do this like day 9 style. Where it's like type 1 in chat if you want to do whatever. It's like choose your own adventure, right? Type 2 in chat. So one thing we could do is I could, this is more of a show and tell on my side, but I could show you some of the relational interpreter stuff I've been working on. One of the things I worked on last week, actually, yeah, last week I think it was, maybe a week and a half ago, is a relational interpreter that handles error messages explicitly. So normally when we write these relational interpreters, if you do something like a variable lookup and the variable's not bound, you just fail, right? So one of the things I've been playing with is explicitly encoding the error messages so that you will get back a special value, which is unbound variable. And in fact, it can have more of an error message than that, even saying which variable you tried looking up was unbound. And the idea is that then you can run your program backwards and say, here's the error message I want to generate, start enumerating scheme programs that when you evaluate them in scheme or racket or whatever, will give me this message or could give me this message because there's some non-determinism in scheme, or well, not non-determinism, but scheme spec is underspecified with respect to evaluation order in many cases, in particular with the case of evaluation of arguments to a procedure call. So basically you can say, here's the error message, start enumerating all the possible scheme programs that could give me this error message when you evaluate it. So that's one thing we could do. So that's kind of neat to look at. So another thing we could do is we could actually do some like real live coding and try working on something that hasn't been done before. One relatively simple thing I think would be adding cond to a relational interpreter. Another thing that'd be kind of neat would be adding eval to the relational interpreter. And I think actually adding eval is pretty simple. It's I don't know why I haven't done it before, but I added apply recently. So it seems like, hey, you got apply, variadic functions should have eval as well. So that's one thing. That's another thing we could do. And then the third thing we could do is something way more speculative. There are a bunch of projects that I have some idea maybe how to implement these things, but going to have to actually work harder. It's not. I don't know off the top of my head how to implement them, and so we could work on one of those. Like one of those would be like adding match to the relational interpreter, or working on the tree automata stuff, trying to get the tree automata stuff integrated, trying to miniKanren, trying to work on a relational abstract interpreter, or things like that. So so those are more researchy. Those are much harder type things. Those are I've got some idea what I'm doing, but not really. So be fumbling around. I'd have to explain in some detail sort of what the problem is. That's sort of a multiple Hangout level collaboration. So anyway, maybe one approach would be to work up to that, right? So let's maybe we shouldn't dive into the research level work up front. Maybe we should kind of dip our toes in and try something a little easier. And then work our way up to like real kind of open-ended research projects, or we could just say, "Hey, let's just go for it, and we'll do something really hard." So anyway, what do people want to do? How about this? We'll try the day 9 poll. So type 1 if you'd like to see the explicit error handling relational interpreter. And we could hack on that, maybe add some new errors. Type 2, if you would like to work on the eval and cond, adding those to the relational interpreter. And type 3, if you want to do something more open-ended, more researchy, more don't really know what we're doing, just go for it. or type 4 if you want to if you have some puzzle you want to share, and we can hack on that together also. That's another. Okay, so 3. Zachary's going for 3. That's a going for the gusto. Okay, Daniel's got a 2. David's got a 1. Okay. We're getting the full spread here. Any tiebreakers? Well, Nahal said eval sounded fun, so that's, I guess, a 2. Well, how about this then? Let's go for, okay. How about this? I don't think it's going to take too long to show off the explicit error handling interpreter. So let's start with that, and if people think it's cool, we could hack on that a little bit and add some more explicit error messages. I think once you see how it works, you could add your own error messages, and I can tell you what the open problems are that I'm aware of, because the code isn't as nice as it could be. Okay, so we could show that. People want to work on that some more, we can talk about some more. Otherwise, we could then go and work on adding eval and cond to the relational interpreter, and I think that would be fun. And depending on how that goes, I guess what I really should do, and maybe I'll do this at the end of today, maybe I could lay out some of the longer-term research projects, and we think about that some. Okay, so let's do the relatively simple thing. It's relatively simple because I've already written it, and that's the error handling relational interpreter. In fact, I don't remember if this code's on GitHub or not. I'm always adding repos and stuff, or I'm always building stuff, and oh yeah, hey, it's on GitHub. Yay, it's on my GitHub. Webbird error handling relational interpreter. I'll put the link in chat, and I'll do some screen sharing here. Let's see. Here it is. If anyone wants to play along, this is all the code. And let's just go ahead and kind of walk through what it does. So, screen share some Emacs. All right. Okay, and I guess I should, just by way of background, I should say maybe a little of the motivation for this, or where this idea came from. I guess there are 2 motivations. One motivation is that with miniKanren, we have this kind of amazing technology in terms of relational interpreter and things like that. The implementation of miniKanren has different design decisions than other logic programming systems and things like that. Not that those aren't advanced in their own ways, but miniKanren has kind of its own niche, and it's an interesting niche, and we can write some really cool programs that I haven't seen before. But one thing we're still looking for, I guess, is kind of like, what's a killer app of miniKanren? What's a killer app of a relational interpreter, right? So it's like, why would you care about doing this other than just sort of the intellectual curiosity? And I do have some sort of longer-term ideas of how this technology could actually be useful. And of course, people are using miniKanren now in industry and stuff. But I think the way they tend to use it is more like an embedded prologue, where they're happy to use some of the non-relational features, which is fine. That helps solve their problem, then great. In terms of the purely relational approach, the stuff that runs backwards, that's been harder to figure out, what's actually useful about it. And some people complain, hey, this isn't useful. It's like, well, maybe it's useful mostly from an inspirational standpoint, or how changing how you look at programming, which is cool. But maybe there are some sort of low-hanging fruit uses of these relational interpreters. And one thing that seems pretty obvious, a possible use case, is with testing. And that could be, and it seems like there are at least 2 things that are related from a test standpoint to some of the things we do with relational interpreters. One is things like quick check in Haskell. And I know there's a similar thing in Clojure and lots of other languages where it's axiom-based testing, where you write down properties of your programs, and then you have this test system generate lots of tests that will sort of randomly maybe test this property for many different inputs. So you're doing sort of like unit testing, but the unit tests are all generated. You can generate millions of tests like that. So that is similar in that you're writing down specifications or properties. The thing about miniKanren was with these relational interpreters, you're actually writing down the full semantics for the programming language. So you should be able to do, that should, in theory, work pretty well with property-based testing. And in fact, it should be even more powerful in some ways, or at least have kind of a different feel. So that's one thing that's test-related that seems in the same space. Another thing that seems in the same space as test-related is fuzz testing. And fuzz testing is used, like John Reger at Utah, for example, uses fuzz testing to find errors in C compilers. And in that one, you want to just throw lots and lots of stuff at a compiler or other piece of software and see if it breaks or see if you can trigger any weird behavior or certain behavior you want to find, like an error message. There, you might care mostly about erroneous behavior. You want to see if you can crash the compiler if you have an erroneous program or something like that, or a program that doesn't have a value or whatever. You might even feed in syntactically invalid junk. But one of the issues with the fuzz testing is that some of the fuzz testers, say you want to test C, one approach to testing C is you have a grammar for C, and then you just like randomly generate grammatically correct C constructs. Then you don't really know what they're doing, but then you have to figure out, okay, well, what should the program actually do, right? So there's an aspect of that. Whereas with the relational interpreter, we already have the semantics encoded for the language, and we can run backwards. We can say either just give me lots of miniKanren programs, or give me programs that give me a certain value, right? So that's kind of an interesting idea. And in particular, for fuzz testing, maybe you want to be able to trigger or generate error-generating programs, right? So you're working on a compiler, and maybe you want to make sure your error testing is right. So you want to generate lots and lots of programs that are supposed to give you a certain error, and then feed them through your compiler and make sure they work. Okay, so like this might be useful for testing Veneer actually. Let's if we had a miniKanren in miniKanren, we could generate lots and lots of miniKanren expressions, for example. Or if Veneer ends up handling all this scheme, we could feed in lots and lots of programs, right? In fact, we could even maybe do it non-deterministically, all that, probabilistically. Daniel asks, is this effectively the type of val in this version of val expo? Is either a scheme value or a tagged error value? Yes, we're going to have a tagged error value. Okay, so that's the idea behind this. First of all, it's kind of interesting just to see how you write this, and it turns out there's some interesting technical issues. And also, this might actually be useful. I don't know. It'd be nice to have something in miniKanren that's relational but also useful. I mean, I'm not super worried right now that we don't have lots of useful programs in a very pragmatic sense, because I think this stuff is still pretty new. A lot of these ideas or a lot of these approaches are still pretty new, so I think it'll come. But it'd be neat to have something we could show off that's actually more pragmatic. Anyway, so here is a simple version of an explicitly error handling relational interpreter. So we have an expression coming in, we have in, we have val. By the way, this is a little sloppy Joe of me to call it exp. The reason is exp is actually defined in scheme. It's like the exponent. It's like natural log exponent or something like that. Base E exponent, I think, is what it is. Anyway, because that's already defined, if you ever reference exp, right, without a fresh or something, you will actually end up with the function, the scheme function, a scheme procedure, in your list or something like that. In fact, I ran into that problem last night. I was writing something and I forgot to put exp as an input or fresh exp or something, and I ended up accidentally having a list with the scheme exponent procedure in the list, and it didn't unify, and I couldn't understand why my program didn't work. But should really probably call it exp. Anyway, as long as we're careful, it doesn't matter. Okay, so here I'm using some absento. So as usual, we have an expression coming in, an environment, and an output value. Except here, the output value could be an error. Okay, this is the simplest version of this explicitly error handling relational interpreter that I'm going to show you. I've got 3 versions. So each one's a little more sophisticated. This is the simplest one. And in this one, I'm just going to say you get error is a value. Okay, so this simple all caps error. I'm saying that is a legal value, and I don't really care what the error is. I'm just going to let miniKanren generate any program that handles an error. And one aspect about this approach that I'm taking right now, and by the way, I've been working with Michael Ballantyne at Utah on this. One aspect is that you explicitly have to encode your error states. So if you want to handle unbound variables being an error, you need to handle that explicitly in your relational interpreter. If you want to handle closures, applying a non-closure value as an error, you have to encode that explicitly. But anyway, these absento constraints, and actually I think this would run just fine. I think this relational interpreter would run just fine in Veneer right now. So we want to make sure that the error state is only appearing in value, the output value. We don't want it appearing in the expression or the environment. And that's important because when you have quote in the language, for example, miniKanren will happily have quote error, be your input expression. So we're saying error really is a special value. I think when we have the runtime type constraints based on the tree automata, that we'll be able to handle this in a nicer way. We'll actually have a separate grammar for expressions and values, and those will be disjoint or only partially overlapping. So I think we can avoid this sort of thing. This is a little yucky, writing it this way. Okay, it's a little yucky. And maybe there's a better way to write it without using something like the tree automata. But anyway, and the same thing here. We don't want closures to be in the expression. We don't want miniKanren to generate tagged, like quoted closures when we want a closure as the output. So that's kind of a standard trick we use with absento. And we have quote and all that. So let's see something that could generate an error. One thing that could generate an error in this version is lookup-o. So here's lookup-o. That's going to generate an error. Normally with our environment lookup, we don't even have a case for the empty environment. We just silently fail. If you look up a variable in the empty environment, you don't get an error like you would in Scheme. You just fail. There is no answer. There's no value that you're going to get produced. Here we're actually going to explicitly model it. We're going to say the output is actually error. Okay. I'm not saying what type of error. It's a type of error. And then maybe we want to have another type of error as well, just to make it a little more interesting. And that other error I was doing was with car and cooter. And you can see I've got all this junky code here having to do with trying to get everything quite right and making sure I'm not doing anything that's unsound. So the code gets complicated, and I would like to find a way to simplify it. Michael Ballantyne and I have been trying to figure out ways to simplify it, but we haven't been very successful so far. But anyway, so another error condition would be if you try taking the car or the cooter of a non-pair in Scheme, that's an error. Okay, so when we're taking the car of some expression E, basically we're going to evaluate E, and there are basically 2 cases. Well, maybe there's 3 cases. Sorry, there are 3 cases. So if we evaluate E in the current environment, we might get back a pair. Okay, if we do, then happy day. Then we're just going to go ahead and return the car of the pair. That's the value. Okay, so that's sort of the standard non-error case. Notice I have an absento error in the value, the output value. So I have to be a little careful here. I have to guard my cases. I want to make sure my cases are non-overlapping. So I want to make sure that val itself isn't an error that was produced earlier on in the program. When I evaluated E, maybe evaluation of E itself gives you an error as a subterm here, or I want to keep miniKanren from sticking in errors, stuff like that. I'm not sure the subcento is actually necessary. It's just being a little, I was being very, very cautious when I wrote this code. I want to make sure everything was right. So some of these subcentos could probably go away. But that's one case. We evaluate E, and we really do get back a pair. Another case is we evaluate E, and we get back error from evaluating E. In that case, the value of the whole computation is error. And then the third case is we evaluate E, but E is not a pair. So E is maybe, I don't know, maybe E is a number, like E is 5. Or so E evaluates to 5, right? So we can't take the pair, or we can't take the car of a number. It's a non-pair. And I think our definition of non-pair, not paro, is also saying that a closure is not a pair. So in that case, we really have a legitimate error, like you're trying to take the car of a non-pair. And so once again, our value is error. Okay, so the flow here is kind of convoluted. Part of the convolution of the code, in addition to having all these absentos with errors and all that nonsense, is the control flow of the program is a little awkward. We basically, if I were doing this in Scheme for real, I might have a call CC or grab a continuation, a jump out continuation, and whenever I saw an error state, I would just invoke the continuation and return error as the value of the entire program. Or you could write your program in continuation passing style or in monadic style and have some sort of error monad, something like that. All those things are trying to get around the fact that the control flow here is a little awkward, because now if an error propagates up, you have to check everywhere to see if you have an error, and then pass that error up basically without doing more evaluation. So that makes the control flow of this program really awkward, and the code's very long. The reason we're not using something like CPS, continuation passing style, or the monadic style, is that as far as we can tell, as soon as we rewrite this code in continuation passing style, we break the strong connection between the input expression, if you want to think of it as the input, and the output value. So it means that we can't really prune our search tree very well. We get in this generate and test scenario, and we get into all sorts of infinite loops. The code's really slow to run and stuff like that. So that's a bigger problem. We don't really know how to handle CPS code. And we don't know how to handle a code that's written in small step very well in the same way. And so, for example, Daniel's asking, or saying a CESK variant of this kind of error testing might come in handy to determine security vulnerability triggering input to a program. Absolutely. That's exactly the sort of thing I want to do. In fact, I'm also now working on some abstract interpreters in miniKanren with Thomas Gilray and Michael Adams at Utah. The CESK machine is a small step machine, and it behaves to some extent as if it's been CPS'd already. And once again, that seems to break the connection between the input expression and the output value. We don't get good pruning behavior. What we end up with doing is, basically the technical explanation is that once you CPS your code, all of your serious calls end up being tail calls, and you don't actually look at the final output value until you reach the base continuation or the empty continuation. So you're doing all this work calculating a program, but the problem is you might not know what the program is. X could be a fresh logic variable, right? Maybe you know what the val is, but X is partially or completely fresh. And maybe at some point you should be able to recognize that exp and val are inconsistent, but because there are infinitely many exp instantiations, you'll just keep instantiating exp to more and more programs, and then checking and seeing at the end of your program that exp and val are inconsistent with each other. Like maybe exp is cons, exp could be cons of E1, E2, where E1 and E2 are fresh logic variables, and maybe val is 5. Okay? I can tell you as a human immediately that cons E1, E2 is not going to give you 5. Okay? But, and in fact, if you write your code, your relational interpreter, write your relational interpreter in the standard way, it's not an issue. because actually, let's see if we have a cons here. Yeah. So here's cons E1, E2. And notice that we check the value. We compare the value. We say the value has to be a pair, right? So if val was 5, this would immediately fail. The problem is as soon as we rewrite our code in something like continuation passing style or monadic style, I believe is also going to have the same problem, or as a CESK machine or a small step reducer with a transitive closure operator. Ignore these big words if you're not sure what they are. But basically, if we rewrite the interpreter in a slightly different style, we can break this connection between the expression and the value, right? So we're kind of cheating in our interpreter. Like we're asserting something about the value before we actually evaluate E1 or E2. And we can kind of get away with cheating this way to cut off the search when it's when exp and val are inconsistent, at least at a type level. But as soon as we CPS our code or go to small step or whatever, this connection between exp and val becomes more tenuous, and we actually have to pick an E1 and E2 and evaluate the entire cons expression down to an actual value before we compare it with 5. And there are infinitely many cons expressions that we can instantiate if E1 and E2 are fresh, and every single one of them is going to fail. So we have infinitely many expressions that all fail. That's the perfect recipe for an infinite loop or divergence in miniKanren. So that is why the CESK machines, or small step interpreters, or CPS interpreters, or monadic style interpreters, that we've been having so much trouble with those. We don't know how to get around that problem. We've tried a bunch of approaches. We have some partial solutions, but we just don't know how to do it. So if anyone can figure that out, I'd be very, very interested in talking with you. Okay. See, Zachary's asking, wonder about the possibility of testing firewall IP tables, netfilter, ntables, pf configs. That's a very interesting idea. So yeah, I mean, obviously we don't just have to have relational interpreters for scheme, right? We could have any formal system that we can model with rules. So something like firewall rules would be actually very interesting to model. That's a very good idea. And then we're starting to act as miniKanren as sort of a model checker, right? Maybe checking protocols and things like that. miniKanren might need some extra bells and whistles. I've talked to Nahal about model checking with tools like spin, use like linear temporal logic and things like that. Be interesting to see if we could make miniKanren do better at modeling protocols and so forth. Daniel says, but CESK backwards is slow. Well, yeah, well, it's slow because, unfortunately, because of those reasons I just talked about. I mean, there's no reason it should be particularly slow, but because of breaking the connection, it's the connection between the input and output makes it slow. It's unfortunately. Yeah. Yep. Orchid asks, could Kanren itself be given first-class continuations? That's a very interesting question. I'm not sure. I've thought about this. I thought about that like 10 years ago, and I haven't really revisited it. I'm not sure what the continuations would be. One of the interesting properties of miniKanren is that miniKanren only has first-order unifications, right? So, we can treat lambda as a data structure and use closures here as the value of lambda, but we can't do the normal tricks you would do with scheme, where you could represent lambda as an actual scheme procedure using a lambda here, right? Because we don't know how to unify procedures. An interesting property is almost an emergent property, is that if you, however, write a scheme program inside of a relational interpreter, because that scheme program is running under an interpreter that has a notion of lambda, has a notion of lexical scope, knows that lambda is a binding form because we have this lexical environment being passed through and all that, the scheme program underneath actually can use lambda as a first-class value. And if you wrote a scheme interpreter in scheme running under the relational interpreter, that you can write a true higher order scheme interpreter as just a scheme function running in miniKanren. So that's kind of weird. miniKanren's is, I mean, I guess it's not really that surprising, but miniKanren's is first order language and doesn't know anything about lambda, doesn't know anything about the scoping or binding of lambda. But if you write a program inside of the relational interpreter, that program inherits the higher orderness and the lexical scope of lambda from the interpreter running above it. Very, very powerful property. Very powerful indeed. And so one way to approach some of these problems would be to write a miniKanren interpreter inside of Scheme, inside one of these relational interpreters, and then that version of miniKanren should know how to handle lambda and higher order functions and things like that. So you might be able to get that behavior in sort of, through treating this relational interpreter as a meta interpreter. I'm not sure. I've played around with it a little bit, and I've got some ideas about how to make that easier to do, more efficient, less awkward. Yeah. So, but I'm not sure how to do it, just at the miniKanren level in a way that makes sense. I'm not exactly sure what the continuations mean. So those are all good questions. All good questions. Okay. So I don't want to spend too long on the error-generating interpreter, but that's the simplest version. Let me show you the next version up. This is error interp specific. Now we actually, so last version we only had error as the value. This version is going to have tagged errors. So for example, here is an error. Here we're saying, instead of just evaluating E1 and getting error back, we're getting an error and a message. So we have a list with an error tag and then a message. And we can see what one of these messages looks like if we go back to car. So here's when a specific error message looks like. Here, we've attempted to take the car of a non-pair. So that's our error message. And in fact, we can even say what the value of the non-pair is if we want. Now, of course, when running backwards, we can leave any of this stuff fresh, right? So we could just have error.message, where message is a fresh logic variable, and then let miniKanren decide what it wants to fill in. So we didn't lose any of the power. It's just strictly become more expressive. But we could also say, when we run it backwards, we want a specific error. We want an attempt to take car of a non-pair, or attempt to take could of a non-pair. And we could even say what the value involved, what the non-pair is, and instantiate that as much as we want. So this gives us actually a lot of expressive power when running backwards in terms of the sorts of errors we want to generate. And I can just show you real quick. Actually, let me just go ahead and run it. Interp specific. Yeah. And so let's see, what's a good... All right, so let's, fun one, it would be, well, okay, I guess we'll just, here we go. Here's a simple one just running forward, basically. So we can say we want to evaluate this expression, this lambda expression, which has a fresh variable x in it, or sorry, you have free variable x is not bound. So when we run this, we're going to get unbound variable x as the error, right? But if we want to run it backwards, we could say, look, we have some expression q, and we want it to produce, when running backwards, the error state unbound variable x. So give me a program that when we evaluate it, gives me unbound variable x. And sure enough, x is unbound by itself. There's no lambda wrapped around it. Here's another one, cons x onto something. Things like that, right? So we can start generating that sort of error, or we could generate another error would be the attempt to, I guess I can do this. So if I run it forward, if I want to take cons, I think I've got quote in the language. Sorry, if I take the car, quote 5, let's see if this works. I remember the language I'm interpreting. That didn't work, so I guess I don't. That's not a value. So how about I take the car of lambda? I think this will break it. Yeah, there we go. Apparently I don't have 5s as non-values right now. Oh, non-pair constraint is also kind of useful in miniKanren as a constraint that we don't currently have. Anyway, So yeah, so here we're taking a car of a procedure that we got back from Lambda, right? And of course we can see our, oh, okay, so this is, what? Okay, this may be an error in my interpreter. Closure. So, okay. Yes, I'm definitely not supposed to have that in here, so, or as a message. So let's, am I, do I have an absento? I'm saying closure can't appear in, okay, that's, I'm very confused. Why would it be putting a closure in there? That should not be, I don't want it taking a car. Oh, I'm taking a car by closure. Oh. Yeah, so it gets really tricky with car and cdr. So that's like not legal at all. So what's happening is this lambda xx. This is definitely an error in my interpreter logic. If I do lambda xx, I get this list, right? Closure xx. So I get this closure object. But the closure object is supposed to be that's supposed to be an atomic value, right? Like that's not something you're supposed to be able to take cars of and stuff like that. That's like taking the car of a procedure. So I'm being a little sloppy here. This is once again where I think the runtime type constraints with the tree automata will really come in handy, because then I'll be able to make sure that I think it'll be easier to express that I shouldn't be able to take cars of closures. So yeah, so we can try patching this. You're trying to prove that this is all correct is actually kind of tricky. So this is an example of sort of where I'd like some proof techniques or better type system or like some type system to help me with this. So basically, when E gets evaluated, if it's actually giving us some sort of pair, we want to make sure that pair is not actually a closure. So to some extent, we want to say val is not a closure. And similarly here with cdr, if we're going to return val, that val better not be a closure. All right, so let's see if that fixes the problem. And change one of my answers. That's not surprising. Okay, let's go back. Fine. Okay, now let's try to carve it. There we go. And that should be the only answer I get back is this run star. Okay, good. That's much better. So there we go. I got into trouble with the lack of types in miniKanren. Okay, so hopefully tree automata stuff will really help with that. Anyway, now I want to run it backwards. So I could say, give me an expression that will produce this value, this error, right? And hey, came up with car lambda. Cool. Give me another one. And that's right. Cons of car of lambda would also do it. And of course, I can also say things like, put in a logic variable here. Like I don't care what the object is. Maybe xy here, and give it a little more freedom to come up with what it wants to do. Oh, I think that has to be a dot. No? Here. Oh, it needs to be a back quote. It needs to be a back. Here we go. Okay. Yeah. So it filled in. So y is going to be closure. Sure. Or I can make it even more free. I can say, hey, I just want some error. I don't care what the error is. It could be attempt to take car. It could be unbound variable error. Yeah, first one's an unbound variable error. If I do 10 of those, attempt to take car of non-procedure, unbound variable errors. So we're getting a mixture. Attempt to take cdr of a non-procedure, right? So we're relaxing the sort of error we want. Let miniKanren do whatever it wants. Okay, Nahal asks, when you run backwards, how did it know to use x as the parameter to the lambda form? Yeah, it was. Daniel pointed out it was part of the error message. So if I go back, you know, in this case, I'm specifically saying I want closure XX, right? Like I could say closure foo foo, and it'll give me foos in the answer, right? So that's if I really want to overspecify things, right? I mean, obviously, it probably doesn't matter too much to me what that is. It's probably more like X body is what I really care about, right? I don't care what the argument is, and oops. So yeah, maybe putting logic variables in there is probably more reasonable. But if I specifically want a certain type of answer, I could feed it in, right? So it gives me a lot of flexibility. There is one area where it doesn't give me a lot of flexibility. And obviously, I've only got a couple of error types here, right? So it could obviously add many more types of errors. But one area in which the behavior I get may or may not be what I want is in this case. Here I'm saying I want to evaluate this expression. So this is an application of applications. Okay, W applied to X, Y applied to Z. Well, all four of those variables are unbound, right? I don't have lambda X in the program or anything like that. So all of those are unbound variables. And Scheme doesn't specify anything like left or right evaluation order. It's not saying like the W is going to be evaluated before X or Y or Z. A Scheme implementation is allowed to evaluate the arguments to an application in any order. So it could evaluate the Y applied to Z first, or it could evaluate the W applied to X first. And applying Y to Z first, let's say, it could evaluate the Y or the Z first. So Z might be the first unbound variable found, or X could be first, any of those four. If I do a run star, I'm only getting back one error. I'm getting back the W is unbound. That's because in our relational interpreter, we actually picked an evaluation order, left to right. So we're only getting the first error. But a different Scheme implementation might actually not produce this error message. It might say that Y is unbound instead. So here we're assuming an evaluation order. We might instead want to relax that and try all the possible evaluation orders that are legal and consistent with Scheme and give us back all the errors. And that's the third version of the interpreter. And it's called error interp specific all. The all is because it produces all the answers, all the possible errors. I'll load that version. And I need now to fix the those problem with the closures on both of them and these other interpreters as well. But anyway, so if I go down to a similar test, I go back to the same test, and now when I run it, it actually is going to give me back all four possible errors, like that. Okay, so depending on the evaluation order, I kick back W, X, Y, or Z. So really what this interpreter is doing is giving you back all the errors that you could get from any legal implementation of Scheme. Okay, any single implementation of Scheme is going to give you one of these errors, but it's up to the implementation. It's implementation specific which one you would get. So that's a little bit of non-determinism in miniKanren, letting you decide how you want to do this. Okay, and I think if I remember correctly, the code is actually shorter for this because miniKanren wants to try all the orderings. You normally have to explicitly cut off to make sure you don't have kind of duplicate answers. So that's kind of a fun thing, and I guess I should go ahead and fix these other two interpreters up to make sure that I'm not going to run into trouble here. Focus answers. Let's do that. yeah, so here's car and critter. So when we're actually ready to produce an error or a message, and the same here with critter. I'll change the other interpreter. Similar sort of thing. It'll be all today. It's so easy when writing these interpreters to make mistakes like that. Once you have car and critter in language, especially once you have quote, it is very, very easy to have your code allow miniKanren to start playing these games, where miniKanren is very happy, like, hey, you want a closure? Fine, miniKanren will start building lists with quote closure in it and stuff like that, right? It'll happily build up a list for you, where really you want to treat procedures as basically as atomic objects that you're not allowed to manipulate, other than calling them. Okay, so that's the error explicitly error handling interpreter, and some questions there. Well, one is just adding more errors would be cool, and seeing how that behaves. Another thing that would be interesting would be trying to figure out, is there a way to write these interpreters with the explicit error handling where you don't have to go through all this trouble of handling the errors specially in every case. I don't know if there is or not. Maybe just do. I mean, I guess you have to handle errors explicitly in a regular scheme interpreter, so I don't see why you wouldn't have to do it in a relational interpreter. But maybe you can make it less awkward. Also, there's all this tagging all over the place, all these absentos, all these disqualify constraints on closures, stuff like that. I'm hoping the tree automata constraints will help with that. I'm not sure. And then finally, there's the control flow issue of having to propagate these errors back up means that we have a ton of code that's checking for errors in the sub values that are being produced. So that's really annoying. It lets us write our code in a direct style, but it feels like programming under Unix, with C, where after every single call you make, you have to check an error code, kind of old school C programming. It feels very much like that. Every time you evaluate an expression, you have to check to make sure the value doesn't have an error in it. And if it does, you have to propagate the error up. So, it sort of infects all of your code. But we're doing that to avoid breaking the connection between the input expression and the output value. And I don't know of a better way around that. Okay, so Daniel says, this kind of framework might be interesting if made less awkward to get more introspection into the reasons for certain answers. Sure. So you might... Are you thinking about something that would be kind of like tracing or something like that? Or, with a type inferencer, right? A type inferencer, for example, in miniKanren just fails. It doesn't give you a type error, just like you don't get an answer back. So a type inferencer would be another good example where you actually want to know why your program isn't working. I agree. Another way to do this would be, to write maybe a nicer, simpler relational interpreter, or even just like a scheme interpreter in Scheme, and then translate it automagically into miniKanren with all the error handling stuff. So that might be another way to try to make this less obnoxious, is to automate that process so you don't have to do it by hand. Nahal says, do the tree automata have a special property that helps avoid divergence, or is it merely a compact syntax? Good question. The tree automata are chosen explicitly because they have very nice properties with respect to divergence. So tree automata are sort of a generalization of finite state automata to handle trees, not just strings. And they can be used to express grammars, regular types, stuff like that. And the cool thing about the tree automata is that you can decide emptiness of a tree automata. Like, does it accept only the empty language, or are there actual non-empty trees that it actually accepts? So you can do that checking, and also you can compose the tree automata. You can take intersection of tree automata, for example, and you can do that pretty efficiently. So between the intersection and the emptiness checking, you have pretty nice properties in terms of composing arbitrary user-defined grammars and checking those efficiently and seeing if the set's empty, if things like that. So I have high hopes that the tree automata will give us a lot of expressive power and allow us to remove a lot of the side condition code that we have to write, and that's really easy to get wrong, and also to be able to make two disjoint types and things like that. That's hard to express right now. We have to use all these absentos and disqualifying constraints all over the place. It's really awkward. It's hard to get right. Like you saw, my interpreter had an error in it, right? So it'd be very nice to have that expressive power. And the tree automata library is done. Michael Adams and I worked on it. Michael Adams knows tree automata stuff really well, so he hacked one up. And now the only thing that has to be done is integrating it into miniKanren. And honestly, it doesn't look like it's a big task. It looks like maybe 2 hours to integrate it. I want to say 30 minutes, but nothing ever takes 30 minutes. So maybe 2 hours. Obviously, playing around with it and understanding all of the implications of it will take much longer, trying to understand how expressive it is. But assuming the tree automata library works the way it should, and we have lots of tests for it already, so we have some confidence in that, integration in miniKanren shouldn't be a big deal. So I plan to do it this week, and if people are interested in doing that, you can even have a hangout for it. Or if someone wants to pair program or something like that, who's interested in the topic. Okay. Sounds like you could build finite domain constraints on top of tree automata. Yeah, the intersection. Okay, so the interaction between finite domain constraints, tree automata, disequality constraints in particular, absento, all that stuff is really interesting, and it's a little tricky to figure out. In particular, once we go to the tree automata, it seems like we get stuff like symbolo and numbero for free. And a lot of the uses of absento go away, and probably some of the uses of disqualifying constraints go away. But I don't think every use of disqualifying constraint goes away, for example. And maybe not every use of absento. So it's not really clear how awkward it's going to be, because in the beginning we're not going to have disqualifying constraints, and we have to figure out how to add disqualifying constraints. The finite domain constraints, it also feels like we should be able to add those. I'm not exactly sure. Michael Adams has this idea that we might have a theory of symbols, a theory of numbers, or whatever, and then have the tree automata library call out. So we have sort of tree automata modulo some theory, sort of like an SMT solver, if you're familiar with those. So I'm not sure. I'm not exactly sure how that's going to pan out. But maybe we can easily do disequality constraints just over symbols. And that actually would probably be enough to do most of what we want. Something like paro and enforcing something's a pair would be very easy. Enforcing something's not a pair is probably pretty easy. You just write a grammar for that. So I think what's going to end up happening is we're going to write lots of little grammars expressing different types of terms we care about, and then taking intersections of those and things like that. But it's kind of a brave new world. Should be really powerful. Should be really cool. I'm excited about it, and it seems like it's not that much work to add it. So, got a couple other miniKanren things I'm playing with right now, but I definitely want to get that working by the end of this week and see how it works. See if we can. I think it'll make writing some of the relational interpreters really nice, and also it might help with divergence in some case. It might. I'm not sure. My intuition is not good enough to know sort of a priori how well it will work for writing some of the relational interpreter stuff, but I think it will give us tremendous expressive power, and especially if we can figure out even disqualifying constraints over symbols and the tree automata, I think is going to be way, way more powerful than traditional miniKanren. What I don't know is how efficient it'll be. In theory, the tree automata stuff should be fast. There may be more engineering to be done to make it faster. I'm not sure. Okay, so that's the error handling interpreter stuff, and this didn't break anything. Maybe I did. Okay. So I can't check it in quite yet. I need to update the tests because I did change how car encoder worked to keep you from taking the car of a closure and all that. But besides that, that should be all good. All right, so I will check in the updated version of the error handling interpreter in case anyone wants to play with that. I think it's kind of fun, and it'd be fun to see what uses there are. And Zachary, as you pointed out, I think things like fire table rules, or I mean, firewall rules would be an interesting application of this. Another thing I've been playing around with recently is sort of having mutually recursive interpreters, where you have an interpreter that can call another interpreter. And that's kind of fun, because one of the things I'd like to, I mean, I even put up like a little proof of concept of mutually recursive quines. Like, so you have two slightly different languages, and one language generates an expression that's not a valid expression in its own language, but in the other interpreter it's a valid expression, and you can go back and forth and do like sort of mutually recursive quines across two languages. And my proof of concept was just in two versions of Scheme with different operators, so it wasn't very interesting. But it'd be fun to have, you know, I don't know, small talk and Scheme or something like that go back and forth to each other, stuff like that. But the other thing, once you start thinking about, you know, I don't think these are like new ideas, but once you start thinking about having different interpreters for different languages able to call into each other or be able to generate programs for each other, things like that, then there's some interesting things you could probably do with like input and output, right? Like miniKanren's not very good at expressing input and output. Something I've been thinking about recently. How can we make it better in a relational way? One thing you could potentially do is if you want to have a relational interpreter that actually had like print in it, something like that, you could have another interpreter representing sort of the outside world, or actors, or an environment, or something like that, or a network. And you know, you could have them interact with each other, and maybe that would be one reasonable way of doing like little simulations that involved a relational interpreter with I/O. That would be kind of fun. Multi-language quine chain, yeah. So like the quine relay, you know, when I saw that, it's like, yeah, you know, that'd be neat to do, where you have, you know, I don't know if anyone's seen this, but people come up with these 50 language and now 100 language quines, where you have a program that generates, you know, a Scheme program that generates a Python program that generates a Java program that generates whatever, and then ends up being back in the original language. And people have done this now for like 50 languages or 100 languages. So, you know, it'd be interesting to see how far could you do that with just inference, right? Where it's sort of like the quine-generating interpreter, but now we're going to infer a quine between multiple languages. So that's, you know, I knew in theory you could do that for a while, but it was just this week I started playing around with it a little bit. But the languages I have are kind of too close to each other to really be interesting. It'd be fun to come up with more different sorts of languages. Anyway, so that's the explicit error handling interpreter, and so it'd be interesting to try to understand how that might work with something like QuickCheck, or how that might work with, you know, how does that fit in with fuzz testing or whatever. And I asked John Reger about it this week, and he said that, you know, it'd be cool to be able to put in error messages from a compiler like GCC or something like that. You know, if we had like a Scheme interpreter, you know, actually take real error messages from Clang or GCC, be able to put them in as the output, and then generate C programs or something like that. I don't, you know, the complexity of that relational interpreter might be fairly high, and also handling things with effects seems to be harder than handling higher order things in miniKanren. It's kind of weird. Like handling a higher order functional language usually is considered harder than handling something like C, but for miniKanren, the side effects seem to make it harder to be able to prune the search tree and things like that. So I think higher order stuff is actually easier in miniKanren. It's kind of weird. It's sort of different from the way. Well, I guess it's maybe not that different, right? Like in miniKanren, you want to write a relational interpreter for Scheme that runs backwards and generates quines. That's easy in some sense, right? Now we figured it out. You want to add two numbers? That's hard. That's like really tricky. You have to decide which number system you want and stuff like that, right? So things that are easy in other languages can be hard in miniKanren and vice versa. Okay. So I promised that if we get through the error handling interpreter, we could look at um, adding like a val to a relational interpreter or cons. So that was, I think, number 2 suggested thing. So let's take a look at that. And I have some notes that I came up with the other day. Now it feels, this isn't like super live coding because it's like I've already thought about it. It's kind of cheating because I've thought about this problem, but I think it'll work. I think a val is actually pretty simple. I mean, I don't know why I didn't implement a val before. This seems kind of stupid in hindsight. But what I really want to do, what really got me thinking about it was having interpreters in different languages. Because right now, the proof of concept I have of a multi-language quine, the interpreters don't know about each other, and they don't know about themselves. They can't call into themselves, and they can't call the other interpreter directly. All they can do is you can have a run expression call into both interpreters, and that's how you can get the relationality, or that's how you make the interpreters talk to each other. But it'd be more fun if the interpreters could call each other directly, call each other's eval directly. So that's really what got me thinking about it. So actually, maybe we should just change the code for the proof of concept that I put online. That might be the fun thing to change. So let's do that. Let's try that. Okay. So going back to GitHub. Let's try this real quick. Oh yeah, by the way, I should say one more thing. I didn't make as much progress on this weekend as I wanted to because I ended up having a bunch of ideas for miniKanren, so I spent like the whole weekend hacking miniKanren. But I'm working on trying to put together, like, I guess, the mother of all demos for relational interpreters. Because now I've got all these cool, fun things to show off with relational interpreters, like in different ways, like the error handling interpreter and all this stuff. Multi-language quines, So what I would love to have is an interactive web page that shows off all of the different things you can do with relational interpreters, and that's why I think the Veneer stuff would be like super awesome to have like this page full of all these cool things, or maybe a couple pages with links to them, showing off different interpreters and different tricks you can do with them, and having that as like a live online super demo of the power of relational interpreters. So that's something I've been thinking about, and I've been trying to collect all these interpreters and the fun things you can do. So that's what I also want to do this week, is try to get that all working and set up. That seems like that would be really fun to show off. Okay, so let me see if I can bring up the GitHub for the other thing I added, this multi-language quine thing. Multi-quine, here we go. All right. All right, so here's the multi-quine page on GitHub. And if you've seen the fifth element, maybe you know about multipass. So multipass. So this is multi-quine. And like I said, it's not the most interesting multi-quine you can imagine. It's kind of boring in some sense. So if anyone has any great ideas about what languages would be more interesting, right now, kind of miniKanren, we basically can easily handle S expressions, right? Like writing a relational parser, I guess, would be fun, but that kind of brings up its own issues. So I guess we could do like a simple object-oriented language that has an S expression syntax, or maybe a I don't know what else, a concatenative language. I don't know what would be fun to do, but it'd be cool to have two really different feeling languages, even if they were both in S expressions. That would give it more of a feel of a real multi-language thing, and maybe have three different languages with interpreters that you could switch between. Do real, cycle of quines, cycle of language quine generation, that kind of thing. Okay, so here is the code, and got like a little README showing some of the examples. So let's look at the interpreter, or interpreters actually. So we have two interpreters. So we have eval expo lang 1 and lang 2. And I think the only way they differ is that lang 1 has list and lang 2 has quote, or maybe it's the other, or one has list and one has cons. Okay, lang 1 has cons, and lang 2 has list, but not so lang 1 has cons but not list, and lang 2 has list but not cons. And because of that, you can get these multilingual quines. So like here's the interesting answer, the first interesting answer. So here are these kind of twin quines where you can see the quine from language 1, or the expression from language 1. It uses cons. So we have a cons here. So I guess I can pull out the expression here. So that is the expression, I think. No, sorry. What's the expression? Oh, I guess I can just run it. Back to cons. Yeah, okay, so there we go. So this expression has cons. It doesn't use list. So you can notice that there are some occurrences of list, but those are all inside quoted forms, okay? So this is from language 1, which only knows about cons, doesn't know about lists. And that generates this expression. If we look at that expression, this expression calls list, but it doesn't call cons. All the cons uses are quoted, or they're in this quoted list. So this is really showing that one language, doesn't know about the other. In fact, we can even prove this. We can show this in Scheme by undefining list and evaluating, the first expression. That works fine. And the second one, we can basically undefine cons or define it to a useless value, and it works fine. So we really are getting multilingual quine inference or whatever. It's just that our languages aren't that different, so it's kind of boring in a sense. Okay, so maybe we can spice it. Oh yeah, so the other thing I wanted to show you that also is a little, it's okay I guess, but I think we can make it more interesting, is that the query itself, let's look at these queries. So in this query, what's happening is we have P, so we have evaluating expression P in the empty environment to yield Q in the interpreter for the first language, and in the second language we're evaluating Q in the empty environment to get P. Okay, so this looks very much like the twine or twin quine generation that I've shown before, or you could do thrines, three quines, P, Q, R, that sort of thing. But notice that language 1 doesn't know anything about language 2. If you look at the interpreters, there is no call, there's no eval form, there's no way for language 1 to invoke the eval of language 2 or evoke its own eval. So I had this idea that maybe language 1 can somehow eval language 2 or at least eval itself. I don't know. Something like that to make it more interesting. So that's something that would be fun to try. Well, let's just for now try adding. Let's just try adding a val itself to the language 1 interpreter. So let's make sure this is all working. So I can run star Q. Make sure we got our sort of standard of miniKanren evaluator behavior going on. And I'm going to say, I'll just do something simple like XX, and the empty environment should give me Q. Alright, what did I do wrong? Oh, apparently I reloaded. Okay, guess maybe I probably ran it. Let's try again. Okay, cool. So we just have a standard relational interpreter. There's nothing special about this interpreter on its own, other than we care about its interaction with the other one. So I can run it backwards like usual. Let's say we want to generate a closure. Enough because it's lambda x, all that good stuff, right? Okay. Seems kind of slow. All right, cool. Make sure, do we have car encoder here? No. Okay. All right, so we have our relational interpreter. So let's try adding eval to it. Let's see if we can add eval. And I don't know. Put eval kind of up front. We'll do the old school scheme eval or Lisp eval. It doesn't take an environment. We're going to say exp. Eval of E. Okay, so we're going to evaluate E. Okay. Let's see, does that overlap with application? It does. This is where if you really want to be persnickety about things, you would have like a not in invo. Val doesn't appear in the current environment. To make sure that because our environment and application overlap, that we know which one. Actually, not in invo. Okay, I already have that. Good. Because I need that as soon as I have a quote in my language. Good. All right, that's fine. We're all good. Really, technically, lambda should also have that. Con should have that if we really want to be correct about everything. This is just letting us override the build-ins if we want to do shadowing. All right, so that's right. Should be right. So if we want to evaluate some expression, I'm going to call it eval. We're going to end up calling our own language evaluator, but I think we have to do it in 2 steps. I believe we have to do it in 2 steps. So first of all, we want to, we have to remember that E itself is an expression, and that gets evaluated on its own before we do the eval version of the evaluation. So what I mean by that is if we call eval in scheme, actually I can do a Shea scheme because I like Shea scheme's eval better than the R6 one. So eval, if you're not familiar with it, lets us evaluate an expression, like a quoted expression, like data. We can treat data, right, as code. So I can define, X to be quote, or list 3-4, right? So it's just a list. Or I could do list plus quote plus 3-4. Okay, so this plus isn't the procedure plus, bound to plus, it's quote plus, it's just a symbol. Okay, so now I've got this expression, and I can eval the expression, and I'll actually run the code. It'll evaluate this expression just as if I had typed in that list at the read-eval print loop. Okay, so that's how the simplest version of eval works. You can also have fancier versions that take environments, feed in various environments, so forth. But I want to keep it simple. So the first thing we have to do is actually evaluate E in our own language, and I guess the example of that is, if we're doing eval list plus 3-4, quote plus 3-4, this is actually happening in 2 stages, right? So the first thing is we have to eval the list plus 3, 4 to get, you know, to get this expression, and then at that point, then we can, then we can eval the we could, you know, feed in to eval some, you know, function foo that, you know, runs for 1,000,000 years, and then it produces the list plus 3, 4. So, you know, we have to be able to evaluate the expression, the argument passed into eval, just like anything, you know, just for any other call, we have to evaluate the argument. So the first thing we have to do is evaluate the argument. We have to evaluate E in the current environment, and that is going to give us, I don't know, that's going to give us some value. And now we want to evaluate that value. Okay. So we need to make a second call to the evaluator, and now we're evaluating value, but we're doing it in the empty environment. We're throwing away our current environment with all our special bindings and all that. We're just evaluating this in the empty environment. And then, because our output variable is val, whatever the output of that is, that evaluation is, that will be your final value. So I think that's how it works. Well, so let's give it a spin. Does it look like I made a mistake, or does that look okay? You're not an expo. Nahal says, you're not an expo for lambda, has a typo, change the val to lambda. Ah, thank you. Let's see. Oh, there's no lambda. Thank you. Thanks. Okay. So I think that's right. Does that make sense to everyone, or is my logic flawed? Why use the empty environment? Okay, so that's a good question. We could evaluate it in the current environment. Usually the eval gets called in a different environment. This is not using the current environment. It's normal semantics for eval. So let me see if I can show this. So like I'm going to define x to be 5. Okay, and now I'm going to eval quote x. Okay, so I'm valuing the symbol x. So that's going to act like a variable. Whoa. Huh. So I guess in Shay it's using the current environment after all. So we could use. So if I give it y, is it going to give me an error? Say something down. Yeah, that's the same as typing y. I go. All right. Well, that's a good question now. So this is a semantics thing. Like we have to decide how we want our eval to work. So do we want it to work in the empty environment, or do we want the current environment? I guess if we want to, you know. I guess if we want to follow the scheme thing, let's see. It probably doesn't use local variables. Okay, so do you have an example of that? Like if it was in a let. Yeah, I guess this is only for globals, right? So let's try. So if I do like y6. Does it know about y? Ah, good call, good call. Okay, yeah, that's right. So it only knows about the top level environment. Interesting. So it knows about like top level defines, but not about like the lexical variables. That's a good point. Okay. Well, all I can say of that is screw that behavior. I don't believe in top level definitions. That's what I'm claiming. I don't know. Daniel asks, wouldn't it have to know about top level defines? For example, define plus. Well, we're treating plus as built in. So Wuho United, I think, is That's a very good point. Actually, I mean, everyone's bringing up good points here. We have to decide how we want to do it. We don't have define in our relational interpreter. In fact, it'd be interesting to add define. That'd be cool to try that. I've always hated kind of top-level define in some sense. I always feel more comfortable with rex. Like the top-level semantics of these programming languages usually are kind of underspecified. So since it's only using a top-level environment and we can only create lexical environment, I think we are allowed to get away with having the empty environment. I think that makes sense. Plus, or whatever, is actually, because we're calling our interpreter recursively, it will get plus if plus is built into our relational interpreter. So we should still be able to call the primitives in our interpreter. If, however, we were using an initial environment that was non-empty, we would probably want to feed in that non-empty initial environment in this call instead of the empty environment. So I think it works out all right. Okay. Well, I'm claiming this is the semantics that I want. I'm going to use the empty environment. Feel free to experiment, right? Feel free to experiment. So try around with different behavior. The other thing we could do is we could actually take some, eval environment as well, right? And in R6RS scheme, you can pass in an environment that, for example, contains all of the standard R6RS bindings, stuff like that. So you could even recognize a special environment being passed in. So that's another thing you could do. But I'm going to try to keep it simple for now, and I'm going to say, you know what, we're just going to evaluate in the empty environment. So let's see how that works. See how that works. Kind of how I want to try it. But I think there's more than one way to do it. Sure. In fact, R6 handles it differently. You have to specify an environment, I believe, for R6. Okay. Let's, I guess to load this thing. Load interp. Sim. All right, well, it's slowed it down. Doesn't really surprise me. I put the eval pretty early in the interpreter. Like you can change, you can force or encourage miniKanren to find answers that have a particular shape or subforms in it by reordering in the cand, the language forms, right? Like if you put quote first in the cand, the way cand works is the search is biased, so you're going to get lots and lots of answers with quote in it. If you put quote at the very end, after call to application and stuff, quote is going to have much less time, and because it's basically a base case and it's coming after all these recursive calls, you're going to get fewer answers with quote probably. Probably you'll get more answers that have like lambda in it, that kind of thing. So you can affect, to some extent, what the terms look like, what the answers look like when running backwards by reordering the code. So if I really wanted to have lots of vowels and code that got generated, I'd probably put it first in the cand, even though that might slow down other tasks or whatever. Okay. A wizard is never late and arrives precisely when he means to. That's true. Okay, so let's try it. Let's try doing something with our vowel. So let's have an expression. Well, okay, I'm kind of chickening out here, so let me just try something simple first. Make sure I didn't break anything too badly. Okay, just evaluate lambda x. Good, get a closure. Okay, now let's evaluate. Let's see, we could do the val of quote of, we have, I think, cons in this language, right? So actually, let's do the cons expression we want first. So let's do, first we're going to do cons of quote 5 to quote 6, if that works. Oh. Now let's do an eval, but now we want to quote the expression we want to evaluate. So the idea is that quote of this cons expression is going to give us back the list cons quote 5 quote 6, and then we're going to eval that. Actually, let's do it in stages. Make sure got everything working. So let's so that should give us back the list cons quote 5 quote 6. Yep. So that's the expression we want to evaluate. And sure enough, if I evaluate that in scheme, it'll work. So let's call eval. And notice I have a quote outside of this whole expression, right? Because there's an extra layer of scheme evaluating everything before the relational interpreter even gets it. So in theory, this should give us back 5.6. Yeah, it works. Okay. Now what do we want to do? So let's try writing something backwards. Let's see if we can generate any evals. Let's say we want, I don't know how likely this is going to be. Say we want 5.6. Can we get it to give us a program that has an eval call on it? Quote 5.6. Okay. Hey, look at that. Whoa. Eval quote of quote. Well, that is correct. That is correct. That's absolutely correct. I just put another quote in front of it. Okay, it's being lazy. miniKanren doesn't like to do much work. Cons quote 5 quote 6. That's right. Okay, now it's getting into the stupid lambda stuff. Whoops. All right, let me do like a run 10. Eval of quote cons. This is it. That's the answer we came up with. So it works. That's pretty cool. And look at this one. Cons of quote 5 to eval of quote 6. All right, I only do like 100. Whoa. Oh, this is kind of cute. Look at this one. Eval of this application is going to give us quote of cons back. Yeah, I like that. Wait, what the? What? Is that real?
I put it at the scheme top level.
All right. Dan, how you doing?
I'm managing.
You see, we just added eval to the interpreter, a relational interpreter, right? So let's try it. I'm going to try this. Okay, but I want to try running this in a Shea scheme, not Vicari, because I like its eval better. So let me just grab the answer. Okay. So save the answers for posterity. And okay, let me start up. All right, let's try it. Oh, that's weird looking. What? Oh, okay. Yeah, that. Shall we try generating a quine now? I wonder if there are any quines that use eval. Do you know, Dan?
Probably a lot of them.
All right. Well, let's try. I have to say that answer. I'm a little. I mean, I know theoretically that should have worked, but that expression is just kind of bizarre. Okay. All right. So like I said before, it kind of slows things down because we have so many. Because I put the eval too early, I think. Anyway. So run Q. Let's do this again. Let's see if we can do a quine. So Q, empty list Q. empty environment Q. Let's do a run one. Let's see. Didn't do anything? Okay, got one. I think that eval up front is definitely slowing things down. Okay. I don't know. Oh, wait, that one has a vowel in it. That one has a vowel in it.
Where?
First one didn't, but this one does. Okay, let me grab those. Okay, let's try sticking them here. And let's try validating as a quine. Let me start up Shay again. Switching between the schemes here. All right, so let me grab the expression is this part. Okay.
Isn't it about?
It works.
Can you find something that's not quote quote nil?
Well, the next one have a vowel. Maybe. All right. Okay. All right. Let's try doing like a 5. So that'll take a second. Yeah, that's kind of weird. Now I got some other ideas. So the more interesting part will be trying to hook up the two languages, the two interpreters, to each other so they can call each other's vowels, right? Here you go, Dan. It's a voweling on a vowel call.
I don't think that one qualifies.
Why?
Because this is the same result as the other
No,
one.
it's not. It's a voweling a vowel. I take that back. It's a voweling a call to a vowel, right?
That's true, but there's a quote sitting on that vowel, which means that a vowel quote is just the same as a vowel quote quote nil. So
sorry.
Now, is a vowel one of your lines in your interpreter?
Yeah, that's what we just added.
Okay.
All right. Well, I don't know. We need like to generate a million answers or something. Okay. So Dan is unimpressed with a vowel quote quote empty list. So we'll see if we can get a better one. Seems like this interpreter is not so fast. So yeah. Let's see. Are there any other cool vowels? My guess is okay. Here's one of the 3 quotes, Dan. Does that make you happier?
Hard to say.
It's hard to say, right? Okay, well, I'll let that run 15. Oh, wait, there's an eval in the Lambda application. Okay, Daniel pointed out we had a more interesting eval, so... That's a valuing a variable lookup. Oh, okay, with the variables that Dan's favorite quote. Well, hold on. Here's the yeah. What about that?
And
That's good. That's a good one.
if you were working, I'd understand, but you're watching Will. Why aren't you keeping me company?
Because I'm watching Will. First time in 7
Wait a minute,
weeks?
is this live?
Yeah.
Yes. Hi, Mary. You're on YouTube.
Say hi, Will.
Why are you watching Will? I thought it was one of your YouTube things or something.
Well, it was going to be on YouTube in a minute.
We're going to become famous.
Okay. Well, so we did find in eval, Dan, that it's doing an application.
Wow, that's pretty good.
All right. Do you want to say hi? Now we have this unexpected pleasure and rare treat of having Dan join us.
Run.
So, in case anyone doesn't know, this is Dan Friedman. He's a professor at Indiana University, and he's author of The Little Schemer, Little Lisper, The Reason Schemer, the season schemer, a little Java, a few patterns, essentials of programming languages, and a bunch of other things, and kind of kept Scheme alive for a decade or two, and a bunch of other things. And also known for several students, including Matthias Feleisen, who's like the father of Racket, and Dan was also my advisor. So
some people don't have pictures.
Some people don't have pictures. That's true. That's true.
And those who have pictures, I don't know the names.
And ferns. Franz and ferns. Yes, Dan is the Franz and ferns person. In fact,
well, I can't accept that.
Okay.
Franz and I are the people who did Franz.
All right. Well, yes, and so Dan and David Wise are also known for this paper, Cons should not evaluate this argument, which was one of the earliest papers, and perhaps the earliest paper, on streams. What would you say, Dan? Do you think that's the earliest paper on streams, or is there anything else in hindsight when you kind of squint?
I know, but that is not true. Peter Landon, I didn't know then, but you know now. Peter Landon had a paper where he introduced generators. Those generators were functional generators, so therefore they were basically acting as streams.
Gotcha.
What our accomplishment was that cons was the only thing we changed. We just wrote an interpreter and added the operator cons to it, and all of a sudden we had streams.
Well, you know, Dan, that's something the thing about adding to the relational interpreter is lazy cons.
I don't see any reason not to.
Okay. Well, let's look at our answers, and maybe we could just go ahead and add a lazy cons, and then. Okay, so let's see. Do we have any?
You have to decide if you're going to be lazy in the call by need version aspect, or lazy in the call by name aspect. Which
yeah. So
you're going to have to add either a state, or you're going to have to add a set queue, or something like that, setback, or something like that.
I'd probably do call by name for now, but I think with tabling, I've been talking with Michael Adams about this. I think with the store passing style, tabling gives you call by need if you already have call by name semantics. I think that's true. Certainly for like a call by names interpreter, I think that's the case.
Certainly seems like it. I don't know if it is.
Yeah. Anyway, so let's see. Do we have any more fun evals here? So there's your lambda. There's your application of identity function. Let's see. Is there anything else? There we're evaluating a variable.
I like to see the val of a cons somewhere. That's what I like.
The val of a cons?
Yeah.
Yeah. Well, I mean, I think we can just,
Wait, did I see one?
run it for longer. Did you see one?
Or maybe not.
I don't think I saw that yet. But we could potentially run this for a lot further. But let's do that later. Let's go ahead and add your lazy cons.
See what happens.
Yeah, exactly. All right. So the question is, should we take out? Okay, I'm gonna for right now, I'm going to comment out the eval, just because the eval kind of slows things down for right now, and that way we can concentrate on our lazy cons. So we do have a cons in here. It's not lazy. This is eager cons, right?
Mm-hmm.
Okay. So do we want eager cons and lazy cons, or do we just want lazy cons?
We probably need eager cons.
Okay. So what do you call lazy cons? Is it like a $sign instead of an S or something, or like how do you do it?
I use $sign cons dollar. Cons dollars good.
Like that? Or
Yeah, that's what I would do.
okay. Maybe at the beginning. I don't know. All right. So how do we do it? What do we change?
You have to wrap.
Oh, whoops, sorry. We gotta put it there too. Go ahead.
Okay, now, yes, okay, not an M. Okay, that makes sense. So now you only have to deal with E1 and E2.
Yep.
Okay, and you have two options. One is to use something like a lambda nil E1 and a lambda E2, but that makes a mess because you're going to go higher order in bad places, I think. So instead, what you do is you cons, and that's the call by value cons, E1 to an environment, sort of like a closure. And you do
Okay.
the same for E2, and now car and cooter, $ car and $ cooter have to deal with those changes.
So our value, I mean, we should give a tag to the value, I guess. So what
Well, we use the word suspend for each one of them,
so is this a pair of suspensions? What is it?
a pair of suspensions.
Okay, so I'm going to call it a suspended pair as my tag,
If any.
and then I'll have each one wrapped in a suspend.
Oh, you could do that. Yeah. Put the environment in both of them.
Okay. I mean, I could treat it as a real pair also. Is that, I don't know if that's a good idea. Feels like it's safer to tag it.
I think you can try that and see what happens.
Okay, so we want the environment.
Yeah.
Okay.
And now you have to define 2 more operators and you're in business.
All right, so car and cooter.
$ car and $ cooter.
Okay.
Gee, this was 1976. How the hell do I remember this crap?
Da-da-da. All right, so
Maybe the obvious things for car and cooter.
obvious thing.
Which will require you to write eval to apply a val, I think.
Do we need a val?
I think you will. Well, you need the driver of this, whatever the driver of this is. What's it called? You of or something? Oh no, I remember.
Yeah. So, well, I mean, we can recur. The recur is different from calling a val in some sense, right? But you need to nuke your val expo calls and cons. Ah, thank you. Those go away, right? We're not evaluating those yet.
Oh, not yet. Yeah, they're going to get moved to car.
Okay.
Car and $cooter.
So, okay. And now, okay, so what do I do with car now? I'm going to, first of all, so I'm going to evaluate E, right?
Why do you have a not enembo $ cons?
Oh, well, because I'm stupid. Okay. Now I'm going to evaluate E, correct? And E is going to have to be a suspended pair, is that right?
Yes, E has to look like suspend.
So it's going to be this. I'm going to just pattern match.
Yeah, you need to put suspend has to be in there. Oh, okay.
And
so
what was that?
What
Oh, sorry. So this should be E1 and E2, right? Okay. And this is going to be an old environment. So do these necessarily have the same environment? I guess they do, don't they?
Yes.
Okay. Okay. Now that I have a suspended pair, okay, so now I'm going to go ahead and evaluate E1.
Yep. That's it. In that environment.
Yeah.
Your suspended has got a suspended.
Oh, I can't spell it. Suspended. Suspended. Okay. And now I'm going to evaluate E1 and inv hat. And that's going to give me a val. And then similarly with cooter.
Yeah, similarly with cooter, yeah.
And so there I'm going to evaluate E2. Okay, and then the only other thing I have to be a little careful of is the tagging.
I saw lang 2. Is this lang 1 or lang 2?
This is all lang 1.
Okay, because I saw a lang 2.
Well, it should be below, I hope. Yeah.
Oh, okay.
I'll double check. Lang 2. Yeah. Okay, so then the other thing I want to make sure of is we have to be a little careful with their tags. Okay. Be a little careful with their tags. Actually, yeah. Okay, so essentially we only have lazy car and cooter. We don't actually have the real thing, and we're not actually using cons either, right? Cons isn't using the actual cons, so we could get rid of the actual cons.
Wait,
right?
hold on. You have to use. No, I think you're right. This is fine. You're not using actual cons, but you do want to use it to process programs.
Sure, sure. But it's okay we don't have car encoder. We only have lazy car encoder, right? Okay. So let me make sure that
If you're using pattern matching, you're fine. Yes, I think
we don't have car encoder in the language because we don't need it for generating quines.
right. We don't.
Okay, so the suspended. Okay, so I want to make sure the tagging. This is actually the trickiest part of writing these things, is to make sure the tagging doesn't end up in the wrong place. This is where I'm hoping the tree automata will help us. Okay, so we want to make sure that the actual expression doesn't contain any of these tags. And I think that's it.
I think so.
That's it. Okay, so let's try it. Let's try it. Now, so all right, Dan. So give me an expression, please. What's What's the test program?
How about $ car of $ cons of let's say
Do you want omega in the second position or something?
omega in the second position is correct. Yes.
So I could do like quote 5 and then omega.
I think that would work fine. Presuming that all of that will work. Yeah. Okay, good.
All right.
So if this returns 5, it seems to be working.
All right.
Boy, does this bring back a lot of memories.
All right. So let's grab this. Evaluate in the empty environment, and the value should be Q. We got back 5.
Right.
And if we try doing coder, that should be an infinite loop, right?
Well, I think so.
And to make that run 1. Seems like an infinite loop because for anyone who's not familiar with omega, this expression right here, which is lambda x applied to x applied to itself, that is an infinite loop. That's like the sort of canonical infinite loop in lambda calculus or scheme or Lisp or whatever. Okay, so if you ever want to test to see if you're getting lazy evaluation, you can just stick in one of these lambda things or one of these omega things to test it. Okay, so now the real test is, can we run it backwards, right?
That would be a good reason.
So let's first of all, let me save that for posterity. Add these tests in a bit. Okay, so now let's try running something backwards. So let's say we want, I don't know, we want 5 to be the answer.
Right.
And let's try doing this. We're going to take the lazy car of some value, and we want to get back 5. And to quote 5 to anything. That's right. That's right. The lazy cons of lazy car of lazy cons of 5 to anything. That's right. Okay, cool. So now let's just relax it completely. I want some 5s. There we go. Lazy car of lazy cons of 5. And does it become more interesting if we have lazy car and lazy cons and lazy coder and a val?
I don't think you need a val for anything.
I'm just wondering if we get more interesting answers if they kind of start interacting in the interesting way. But are there quines that use lazy cons? Let's try doing some quines.
I have no idea. Tell you the truth.
Well, I came up with this.
Turn around when I was thinking about this stuff. Oh wow!
What?
We got back a quine.
Yeah, but that's the regular quine. That's nothing special.
Oh, that's the standard one.
That's the standard one. Let's see if we can get another one.
Yeah.
Okay, that's
Predicting you won't unless you put an infinite loop somewhere.
Is that actually a quine? What is that? Right. What?
Oh, suspended.
That works. Huh. That's kind of weird. Anyway, that is a quine. I hadn't guessed it. Okay. And let's see if we can get. Hey, there we go. Yep. That works. Now, I guess you don't really need the lazy. Well, okay. To be fair, that _1.
I didn't see that one.
That really could be at this. That could actually be like something like omega that diverges, right?
Oh, yes.
So this does give you more expressive power.
Absolutely.
Is there a way to do other like infinite streams that are interesting?
Well,
You can do like streams of 5 and.
you could do the sequence of factorials.
We could. That's a little tricky just because of the numbers, right?
Yeah, you do have numbers.
Yeah. We could do an infinite sequence of adding to piano numerals. That's easy to do. Successor of piano numerals.
Yeah, that'd be fine. That works.
I actually played around with that this last week. I did a lot of stream stuff without lazy cons, but I did a just using explicit thunks before going to a call by name interpreter. So I actually know that stuff works. So, but I think it's easiest if you have an interpreter with letrec in it.
Yeah, it would be much easier.
Yeah. So, all right. So this would be fun to integrate into. I've got one with letrec, and it's got apply in it and variadic lambdas, and adding a val to that also would be like really cool. So, anyway, that's really neat stuff. That's a quine template. Nahal points out that's a quine template. Equal. Have you ever seen that before?
I don't know.
Say hi to Will. Wait a second. Hold on.
Come over.
Hello.
Hi.
Oh, hi. How you doing?
Say hi, Will. Hi.
Greetings from Utah.
Can you see him?
You have to get all the way over, so he's in it. There you go.
There you go. Say hi, Will. Hi, Will.
Hi. How you doing?
Hey. Wave to him.
We're having a quine party.
We have a friend over.
Lazy quine party.
Shut
Hello,
up.
how you doing?
Oh, wait a minute. Here, sit with Poppy for a minute. We're trying to. No, you got to say hi to Will again.
Okay, sorry, Bill.
Our first YouTube video.
You always have to have at least one, right?
Yeah. Alrighty. Well, that's lots of excitement. Okay, so we've hit our sort of 2-hour little mark. So I think this is really fun stuff. I will check in to both the error handling. Oh yeah, so the other thing we showed Dan was an interpreter that explicitly handles errors. So you can say, I want this particular type of error generate programs that
Produce errors.
that in scheme could potentially evaluate to that type of error.
Oh, I like that.
So we did that for a bit, and that actually brings up a number of interesting technical questions, because even though we can do it, it tends to be a little awkward how we have to write that interpreter. So it'd be nice to find a cleaner way to do it. But I think that's so Nahal, you asked if for the quine template if we've ever seen it before.
Yeah. What I mean is that the _.1, that could be anything in that quine. So you have.
Yeah.
I mean, I guess that seems only possible if you have lazy evaluation.
Yes.
Right. So that just seems interesting. Because most of the
Right.
time.
Okay, so let's look at our canonical quine. Because that one has _zeros in it, but I guess you're right.
Lambda parameters. So the _0 for lambda parameters. But here you have something that could be anything.
I totally missed that. You're absolutely right. So that
caught
That's
the,
a more general answer. Wow, we should definitely.
shouldn't
Okay,
it,
that's a good point.
so are we saying that it can't be just _1? It's got to be a little protected.
Because look at the difference here, right? So in this third answer, I'm going to grab the term. In this third answer, we have a regular cons, a non-lazy cons of _0, right? And say, hey, _0 could be anything. But it can't be anything because we're saying we have a symbolo constraint on _0, right? We're saying _0 really is representing this formal parameter, like lambda x or something like that.
Right.
But the lazy cons is using _1. And _1, that could be any term. Now, we have a couple of constraints on absento constraints to handle shadowing, but that could be anything. That could be an application. That could be an infinite loop. So that really could be any term. It doesn't have to be something, an expression that terminates. So you're absolutely right, Noel. This is I haven't seen this pattern before. You do need something, or I should take it back. I have seen this pattern before, but only inside of like a lambda or something like that, right? The body of a lambda, you might see something like that if the lambda's not applied. But yeah, but that really is showing the laziness off. So absolutely, it's a very good point. I missed that. Okay, so I will check in this code. So the two pieces of code we played with are the interpreter that can explicitly handle errors, and then the other is this sort of proof of concept of multilingual quines, and we're adding some interesting features. We've got apply, and we also have lazy cons, car, and cooter. So I encourage people who are interested to try playing around with this some more, with the laziness, and we can try adding some streams and things like that. But now also, in terms of mutually recursive quines, it becomes more interesting because now the languages really are differing more. Furthermore, another thing that's kind of cool is, we added that eval, but it'd be neat to be able to have the two languages eval each other, to be able to call evaluators on each other, and that would make it more interesting in terms of doing multilingual quines and that kind of stuff. So that would be another thing to try. Is like we've added eval for our own language, but it'd be neat for that one interpreter to be able to eval into the other interpreter and vice versa also as well. So that'd be really neat. So we got lots of things to play around with, and I think that's it for today. We had lots of good discussion and lots of fun stuff to show off.
Like grandchildren.
Including Dan's grandchildren, which were the maybe second or third most interesting thing on the show. It's a good show when the grandchildren are interesting. At least they're in the top 3. And yeah, and we also saw the latest version of the Veneer system that David's been working on with Orchid, and that now runs miniKanren quite efficiently, actually. So David, who did the Veneer stuff, Dan, was saying that he was running the quines and the relational interpreter and the Oleg numbers, stuff like that, in chicken scheme, which is, a scheme compiler compiles to C, and it was taking like a minute to come back with answers that were coming back in the browser and their JavaScript in like a second or part of a second. So the interpreter is pretty fast, and now it handles all the constraints, all the symbolic constraints. It handles absento and numero and symbolo and disquality constraints. So you really can run all the relational interpreter stuff in the browser now. It's very cool.
The question is, if you stage, like we talked about this morning, those interpreters, before you go to miniKanren, how much faster is it going to be? I think it's going to be significantly faster. If you recall, when Jason and I spoke in Chicago, it's like it's super fast versus never returning, even though it should have. So it's a very powerful tool, staging.
Yeah. So what Dan's talking about is a technique where you can write an interpreter in a special way where you have parts of the environment being static and parts of the environment being dynamic, and you can lift out the static parts. So it's a type of staged evaluation, and it can radically speed up interpreters in certain cases. So it'd be really interesting to try this technique with the relational interpreters, because as our relational interpreters get more and more expressive, more and more powerful, if we can radically speed them up, then I think the style of programming becomes way more appealing and way more practical. So I'm now at this point where I'm trying to figure out, like, how could we really speed these things up? I think there are a bunch of techniques we could use and make them much faster maybe than people would expect.
Let me just, small correction on that.
Okay.
What you said was completely correct, but expressions are also static. So it's the expression and the static environment is at one level, and then you have the dynamic environment at the other. So if you actually have the expression in your hands, then it can do all of the analyses in the static environment way before you actually start running your program.
So it's basically doing partial evaluation then on your query?
Yes, exactly. I don't know what happens when it's not there and it thinks it wants to be there.
Well, I would like the code for a full working version of one of these.
Say that again.
If you send me the code for Chicago,
maybe
I will attempt to relationalize it. We'll see if there's a big speed up.
Oh, I see. Yeah. What we did in Chicago was just on a pure interpreter.
Yeah.
An idea. I have to check with Jason.
Yeah. Nahal's asking if that talk is online somewhere. I don't think it was recorded, was it?
It was not recorded, but as I said,
are there any papers on this that you could point people to who are interested?
Not that I think that they'll be comfortable reading without some sort of clarifications. But I can't think of
well, if you can cough up some code, then maybe we can go over it.
Well, I was going to say, I have to find out and see what the condition of the code is.
Okay.
I don't know enough right now because it was 2 years ago. So.
I know. All right, well, that would be fun to play with. David says, I was actually planning on this. Or, David, were you planning on doing some partial evaluation or stage evaluation, or are you talking about the chicken? And
Yeah. So my original plan for the Veneer thing was to write it in Scheme and then stage it with output pretty printing to JavaScript. So, but that was way too hairy to get done, in a week. So I just decided to do it this way and write the compiler in JavaScript.
Okay, so yeah, I guess we could stage the evaluation at different levels, right? So one is at the level of the compiler, like a Scheme compiler. One's at the level of the miniKanren relational interpreter itself. So you could even maybe do a Scheme interpreter being interpreted by a relational interpreter, and then do this trick to the Scheme interpreter under evaluation. And I think there are different levels you can do this at. Maybe you can even do it at all the levels. It'd be very interesting to explore how that would work out, and if it really does make it faster, a lot faster, this could be pretty awesome. So, yeah, that's definitely something I'd like to explore. Okay, well, I think that's plenty enough for this weekend. But hopefully you saw something that you found interesting and would like to play with. Zach's got a link to Closure Scheme, which is closure to chicken to C on GitHub. And I guess it's a talk. Sorry, it's a talk on Closure Scheme. Yeah. So anyway, thanks everyone for joining us, and hope you'll play around with some of these things. I'll go ahead and check in the code to GitHub. And thanks for joining us. Thanks for the great conversation, and I learned quite a bit. And now we have a version of eval and lazy cons and all that. And maybe we'll see this in running in Veneer also. Very cool. And Nahal says Dan's grandkids are always welcome. All right. Well, thanks everyone for joining, and I hope Dan and Jason will join us in the future also. we've gotten to the point, Dan, where now it's more like playtime, right? Like I've gone, we spent the time where we're talking about how these things work, and now we're actually like playing around with things. So this is the fun time, right? This is like the playtime and investigation time. So this is really cool. All right, Daniel.
I think I forgot what that word means, actually.
What, playtime?
Yes.
Oh, okay. Well, then you definitely need to spend some summertime, some time on Sunday if Mary's not going to yell at you too much. Yeah. All right. Well, yeah, Daniel. Hopefully you can at least catch the recording next weekend and pick up afterwards. All right. Well, thanks a lot so much for joining us, everyone. And I really did learn a lot. It was really fun. So this is the sort of thing that I'm hoping that we can keep doing every week. And thank you, Dan, for joining us also. That was that's a pleasure. You'll have to coax Jason into joining us next time.
Well, he's out of town.
Okay. Well, we have gone over the micro-Kanren implementation in some real detail. So, okay. All right. Well, have a great weekend, everyone. Yeah, more the merrier. And have fun. Have a great weekend. Take care, everyone. And see you soon. Bye. Stopping the broadcast.